The conveyor restart. In 2015, a fatal accident occurred at a Volkswagen factory in Germany involving an industrial robot. During the setup of an automated production cell, an experienced worker was inside the fenced area. The robot was programmed to move and position automotive components, operating strictly according to its algorithm. At a certain moment, the system activated. The sensors and software logic failed to recognize the human presence as an obstacle. The robot executed its standard movement sequence and pinned the worker against a metal structure. Co-workers stopped the line immediately and called emergency services, but the injuries were fatal. The investigation concluded that the robot did not malfunction. It operated exactly as designed. The failure lay in the safety, configuration, and human interaction with the autonomous system. The algorithm had no awareness of a person's presence and followed its programmed instructions. The incident became one of the most cited early examples, showing how automation, without sufficient safeguards, can be deadly even in advanced industrial environments. The unsecured fall. In 2016, one of the most widely discussed incidents involving semi-autonomous driving occurred in the United States. A Tesla vehicle was traveling on a highway with autopilot engaged. The driver was behind the wheel, but relied heavily on the system to maintain lane position and control speed. A tractor-trailer crossed the roadway ahead. The computer vision system failed to recognize the trailer as a hazardous obstacle. Its bright side blended with the sky, leading the algorithm to classify the situation as safe. The vehicle neither braked nor attempted to avoid the collision. The impact occurred at highway speed. The driver was killed instantly. Investigators later determined that autopilot had known limitations described in documentation, but those limits were not always clearly understood by users. The system did not make a wrong choice. It simply could not properly interpret a rare but critical scenario. The crash became a turning point in the debate over responsibility between human drivers and automated systems. It demonstrated how partial autonomy can create a false sense of security, encouraging people to trust AI beyond its actual capabilities. The wrong lever. In 2018, the first recorded fatal collision involving a self-driving test vehicle occurred in Arizona. An autonomous test car operated by Uber was driving at night in self-driving mode. A safety operator was seated behind the wheel, responsible for monitoring the system and intervening if necessary. A pedestrian was crossing the road outside a crosswalk, walking a bicycle. The vehicle's detection system identified the object early, but repeatedly reclassified it first as an unknown object, then as a vehicle, and later as a pedestrian. Each reclassification delayed the decision to brake. In addition, the software was configured to avoid aggressive automatic braking, assuming a human operator would intervene in critical situations. The safety driver was distracted and failed to react in time. The vehicle did not slow down and struck the pedestrian at full speed. The investigation revealed that the system technically detected the person but failed to act decisively. The tragedy resulted not from a single sensor failure, but from a combination of algorithmic limitations, safety settings, and human oversight. The incident forced the industry to reassess how autonomous vehicles are tested on public roads. The silent sensor. In the late 2010s, a serious accident involving an industrial robot occurred at a Samsung manufacturing facility in South Korea. During routine maintenance of an automated production line, a worker was positioned near a robotic system responsible for moving large components. The machine vision system was designed to recognize parts and pallets, but lacked reliable human detection in certain positions. When the worker leaned into the robot's operating zone, the algorithm did not classify him as an obstacle. The robot continued its program task and moved its arm abruptly. The worker suffered fatal injuries before the system could be shut down. Investigators later confirmed that the robot had not malfunctioned. It operated exactly as programmed. The failure lay in the safety architecture and the limitations of the vision algorithm, which did not account for non-standard human postures. The incident highlighted ongoing risks in human-robot collaboration. The machine did not make a mistake in human terms. It followed code that proved insufficient for the complexity of real-world factory environments. Working alone. In the late 2010s, Amazon rapidly expanded the use of robotic systems in its warehouses to optimize logistics. Algorithms controlled shelf movement, item routing, and work pace. The primary goal was efficiency, faster order processing, and higher productivity. As productivity increased, so did the physical demands placed on workers. The algorithm set performance targets based on output metrics, not human endurance. Employees were required to move faster, handle more tasks per shift, and take fewer recovery breaks. Over time, serious injuries were reported at multiple warehouses. Workers fell, collided with moving robotic units, or suffered injuries related to exhaustion. In some cases, the outcomes were fatal. Technically, the system followed its programming. It optimized workflow exactly as designed. Investigations revealed that the issue was not a single malfunction, but the underlying optimization logic. The AI did not account for human limits or cumulative fatigue. This case became a widely cited example of how algorithmic management can indirectly lead to deadly consequences, even without direct machine aggression. The weather shortcut. In August 2012, the U.S. trading firm Knight Capital Group deployed an update to its automated trading algorithm designed to improve execution speed and market efficiency. Due to a deployment error, parts of outdated code remained active on several servers. Within minutes of launch, the algorithm began executing thousands of uncontrolled trades. It rapidly bought and sold stocks without a coherent strategy, generating massive losses. In less than 45 minutes, the company lost approximately $440 million. Trading was halted, but the damage was irreversible. Although the incident did not cause immediate physical harm, its consequences were devastating. Employees faced extreme stress, job losses, and the collapse of a firm that had operated for decades. Knight Capital was effectively destroyed by a single algorithmic failure. Investigators concluded that the disaster was not caused by malicious AI, but by inadequate testing and control procedures. The algorithm followed its instructions precisely. The problem was that those instructions were flawed. The case became a landmark example of how autonomous systems can inflict catastrophic damage within minutes when human oversight fails. The gas alert that failed. In the late 2010s, a hospital introduced a medical AI system designed to assist doctors with diagnoses. The algorithm analyzed test results, medical images, and patient histories to suggest likely conditions and treatment options. It was marketed as a decision support tool, not a replacement for physicians, and quickly became part of routine clinical workflow. In one case, a patient arrived with symptoms that could indicate several serious conditions. The AI analyzed the data and suggested the most statistically probable, but less critical diagnosis. The attending physician, trusting the system and seeing no obvious contradictions, accepted the recommendation without further verification. Treatment was initiated accordingly. Within hours, the patient's condition worsened. A second evaluation revealed that the initial diagnosis was incorrect and that the true condition required immediate intervention. By then, it was too late. The patient died from complications that could have been prevented with timely treatment. The investigation concluded that the algorithm performed as designed within its training limits but failed to account for rare and atypical symptom combinations. The failure was not malicious intent, but over-reliance on an automated recommendation without independent clinical judgment. The case highlighted the risks of treating AI guidance as authoritative rather than advisory. Rushed maintenance. In the early 2020s, international attention focused on an incident involving the use of an autonomous drone in a conflict zone. Official reports, including those referenced by the United Nations, indicated that the drone was capable of operating without direct real-time human control. Relying on built-in detection and targeting algorithms, the system was programmed to identify and engage targets matching predefined parameters. At a certain point, the algorithm classified a person as a valid target. According to available information, the decision to apply force was made autonomously, without immediate human confirmation. The outcome was fatal. Investigations did not point to a technical malfunction in the conventional sense. The system operated within its programmed rules. The issue lay in the rules themselves and the assumptions embedded in the algorithm, as well as the lack of a strict human-in-the-loop mechanism at the final decision stage. This incident became one of the first widely discussed examples of autonomous systems applying lethal force based on machine logic. It sparked global debate about the limits of AI use in military technology and the necessity of mandatory human oversight in life and death decisions. Ignored safety rules. In the late 2010s, a fatal incident occurred at an automated factory involving a machine vision system. The production line relied on cameras and recognition algorithms to track parts, tools, and objects within the work area. The system was considered reliable and allowed equipment to operate at high speed without constant human supervision. During a shift, a worker entered a restricted zone for a brief inspection. According to safety design, the line should have stopped automatically if a human was detected. However, lighting conditions had changed, and the worker was positioned in an unusual posture. The classification algorithm failed to recognize him as a person and did not trigger a shutdown. The machinery continued operating. The worker remained inside the hazard zone without protection. Co-workers attempted to stop the line manually, but there was not enough time. The injuries were fatal. Investigators determined that the cameras and software were operating within their specified parameters. The failure occurred at the recognition level. The algorithm had not been trained to account for certain viewing angles and lighting conditions. The incident became a clear example of how reliance on machine vision without redundant safety measures can lead to deadly outcomes. Skipped inspection. In the early 2020s, a serious highway accident occurred in the United States involving a self-driving truck equipped with an automated driving system. The test run was conducted on public roads, where the algorithm handled lane keeping, distance control, and object detection. A safety operator was present in the cab, but the system managed most driving functions while traveling at highway speed. The truck approached slower traffic. The algorithm evaluated the distance to the vehicle ahead, but misinterpreted the rate of deceleration. It determined that the gap was sufficient and did not initiate braking in time. When the situation became critical, there was no longer enough time for human intervention. A collision occurred. The impact proved fatal for occupants of the passenger vehicle involved. Data analysis later showed that sensors detected surrounding objects correctly, but the prediction model failed to accurately anticipate how the situation would unfold over the next few seconds. Investigators concluded that the issue was not a hardware failure, but a limitation in the decision-making algorithm. The system performed well in standard scenarios, but struggled in complex, rapidly changing traffic conditions. The incident reinforced concerns about deploying autonomous trucks without robust safeguards and continuous human oversight. The warning that came too late. In the late 2010s, a surgical procedure was performed using a robotic-assisted system designed to improve precision and reduce human error. The surgeon controlled the operation while algorithms stabilized movements, filtered hand tremors, and regulated instrument force. During the procedure, the system began behaving unpredictably. One instrument deviated from its intended path and applied excessive force. The surgeon attempted to immediately assume full manual control, but a brief delay in system response and interface handoff proved critical. Within seconds, vital tissue was damaged. The patient was transferred to intensive care but complications were fatal. A subsequent technical review identified a fault in the motion control software module that occurred only under a rare combination of operating parameters. Investigators concluded that the system had been properly certified and operated within approved limits, yet failed to account for edge case scenarios. The incident underscored that even highly precise medical AI systems require robust fail-safes and constant readiness for immediate human intervention. The automatic timer. In the early 2020s, a large industrial facility relied on an automated crane system to move heavy loads. The algorithm controlled trajectory, speed, and stopping points based on position and weight sensor data. The system was considered reliable and operated mostly in automatic mode. During one operation, a worker was present within the crane's movement zone, performing support tasks by design. The crane was supposed to stop if a human was detected in a hazardous area. However, one sensor provided incorrect input, and the algorithm failed to recognize the human presence as a stop condition. The crane continued moving along its programmed path. An emergency intervention was attempted, but it came too late. The load pinned the worker against a metal structure, causing fatal injuries. Investigators determined that the system did not technically malfunction, it acted according to the data it received. The failure lay in the lack of redundant safety checks and layered protection. The algorithm could not perceive what it was never properly designed to verify. The case reinforced concerns that automation without multi-level safeguards can be as dangerous as human error. Subscribe and don't forget to like.